The industrial name for capacitor is also condenser. In business or trade field, this is also termed as, you see, it is always represented by two parallel lines. Two parallel lines. This is the representation of capacitor, or you might say condenser. If you want to show the condenser to be of variable nature, this is the way to represent it. If you want to show that the condenser has been earthed, means you want to show this thing, for that there is one shortcut symbol. The other plate shall be shown curved. So that we have shown over here. You see, what's the principle and what is the basic use of condenser? Now we should cover that thing. Actually, if we want to store the charge, we use this idea. Condenser is based on the principle of electrostatic induction. What we do, we take one conductor. For condenser, there is no restriction that the conductor should be of plate or of sphere type. It might have any shape. Two conductors at a certain distance will form the condenser. So there are two conductors. For simplicity, I have chosen the shape, a very simple one, like a plate. See, this is given the charge. Now it is having some capacity, accordingly it will store the charge. That we know already. But here, another conductor is placed near it, in its vicinity. What will happen? Because of induction, some opposite charge on the inner side, on the remote end or the outer end, some similar charge will be produced. And for this very arrangement, two conductors at a certain distance, not in contact, they are forming a condenser. For this condenser, capacity is given by the ratio of charge and their potential difference. Remember, V here is potential difference. When you talk of a conductor, it's a potential, and when you are talking about a condenser, it is the potential difference in the same formula. So, because of this second conductor, minus and plus charges will play their different role. This will reduce the potential, this minus charge, and the plus charge is going to increase the potential. Suppose by giving the charge to first conductor, it had the potential 10 volt. It's a pure mathematical example. You need a little precaution in grasping this thing. This has plus 10 volt by itself. Minus charge is little away. It's going to produce a minus 8 volt. And this similar charge that is furthermore away, it will also produce some potential, but less than this one because it is distant. So, it will produce a plus 6 volt. So, ultimately what has happened? This has reduced to plus 8 volt. The presence of second conductor itself has simply resulted in the decrease of this potential. And when this will decrease, potential will decrease, potential difference will decrease. When this decreases, capacity will increase. That's the basic idea of condenser, that capacity of one conductor can be increased by simply placing another conductor near it. How interesting and how wonderful it is that capacity of one conductor can be affected, can be rather increased by the presence of other conductor. This is possible, this is miraculous, but this is possible only with electrical capacity. It's not possible with singing capacity or capacity of storing the water. With bucket, it's not going to be possible. This is possible with electrical capacity, that surrounding medium affects its capacity. The presence of another conductor in its vicinity also affects the capacity. So, that's the principle of condenser. Now, you know, this is earth. Earth has negative charge over it, around Earth. The electric field, is 100 volt per meter all around, and always it is vertically downward. If there is a person, its capacity might be considered somewhere in between 100 and 300 picofarad capacity of every person. Now, if we consider the height 1.8 meter, that's little less than 6 feet. If you consider this height, in that case, the potential difference, you see, you might calculate as E into D. This will be potential difference, and Q is given by C into V. You take average value here 200 picofarad, and volt might be calculated by this formula. This will be 100 and D is 1.8 meter. If you calculate all this, you'll find that the total value comes out to be 36 nanocoulomb, means this much amount of charge you are always having on your body with your body. It's given here. For the capacity of condenser, we know the formula, but now for the capacity of Earth, we would consider it as metallic sphere first, which obviously it is not. ये रोक दो इसको, क्या हुआ? किस पे जाएं? मैं बचा दूंगा. If we consider the Earth, obviously it's a quite big sphere having radius 6387 kilometer. That's roughly about 6400 kilometer, the radius of Earth. And according to formula 4 pi epsilon naught into R, if you put the value, it's going to be 1 upon 9 into 10 to the power 9, and you multiply it. Then you'll find the capacity about 711 microfarad. Capacity of Earth. You have to remember such a big thing and such a small value while dealing with electrical capacity. So you can imagine that farad is a quite big and impractical unit. That's why common unit in our discussion, in our daily life, in our study life, it is always either microfarad or picofarad. This capacity is, since in microfarad, obviously it will consider the small one. But again, Earth is such a big size that any charge, remember it's having already minus charge, but any charge that's given to the Earth is not going to make the difference or any impact on its potential. Its potential is normally not affected by simple transaction of the charges. That's why we ultimately conclude that potential of the Earth shall be taken for all practical purposes as 0. And whenever you just use this sign, you simply want to say that the resistance coil or the condenser has been grounded. Anything that has been grounded with the Earth, and if it is having charge, irrespective of the nature of the charge, might be positive or might be negative. If the charged body is connected with the Earth, the charge is bound to flow either to the Earth or from the Earth. That's why potential of Earth shall always be considered at 0, or it is also said that it is neutral. Now, condenser is another name shown by two parallel lines storing charge, and it's compared with flywheel of the bicycle. Why? Because when there is surplus amount of the charge in electric circuit and there is condenser, then obviously condenser will store the charge on it. If the charge is required in the case of deficiency or in the case of low voltage supply, then in that case the condenser is going to just make up the deficiency of the charge. So it can store and it can supply as well. Both the things are possible. One very important terminology goes with condenser. condenser would be given the charge. It will be known as charged condenser. For charging, you see what you do, you simply connect it with a cell, one plate with one terminal of the battery or the cell, and likewise the other. Charge flows from the cell, terminal of the cell, it is charged, but there is ultimately a limit. You see, every property of the condenser depends only on one thing, because there is no connection between the two plates. That's the basic and utmost important characteristic of the condenser, that there is no connection between the two plates directly. There is air, there is insulator, and there is no leakage of charge. But it doesn't mean that you can charge it up to any limit. Any dielectric or the insulator between the two plates will be having some limit. After that very limit, the breakdown will take place and charge will start getting leaked. That is known as dielectric strength. Dielectric strength. This limit has reached, that means after this limit, the charge will start leaking through the dielectric, and this will no more be a condenser because the two plates would get connected. We say breakdown has taken place. For air, this is 30 lakh volt per meter. That means the insulation of air breaks down when the electric field there is 3 into 10 to the power 6 volt per meter. Likewise, you might remember the value for mica and this glass also. One more thing finally, when the two plates are separate, it is a condenser. When the two plates are joined by any method, see, this will no more be a condenser.